guys, so now that we have graphed, we've done a little refresher on graphing inequalities. We are now going to graph our systems of inequalities here. And guys, the best way, you actually, I guess, could plug them both in and see if it satisfies them both. But really the best way to solve a system of inequalities is by graphing. Okay, and I'm going to show you guys what I mean by that in just a second. So guys, we are going to solve this by graphing. And in order to solve the systems of by graphing, you must graph both inequalities. You must graph both, all right? And find the region that satisfies both inequalities. So I guess I didn't need both there too. I wrote both too many times. That's okay. So basically, guys, what we are looking for is we are looking for a double shaded region. Okay? We are looking for a double shaded region because it's going to satisfy both of them. All right? So here's a good little refresher. X is greater than 5. Guys, what kind of line are we dealing with? We're dealing with a vertical line. All right? So, guys, is my line going to be dashed or solid? Is this line going to be dashed or solid, y'all? That is going to be dashed. And are we going to shade up or down? Well, it should be up, but because it's a vertical line, we are also going to shade to the right. That only is for vertical lines. All right, guys? So it's going to be over here at x is greater than 5, or x is greater than 5. So it's going to be a dashed line. So I'll do that here. So now I'm going to do 2 different colors so you guys can see my different colors here. So that is a dashed line, and because it's greater than, we can't really shade up because it's vertical, but we can shade to the right. Does that make sense, y'all? So this is to the right here. All right. Now, for our second line, so that's a vertical line. You can think of the whole VUX thing if you need to, okay? Now, for this guy, your y is less than or equal to, first of all, less than or equal to 4. What kind of line are we dealing with, dashed or solid? Solid line, and we are going to shade down. And because what kind of line is a y is, yeah, this is a horizontal line, or you can also think hoi. So it's at 4, so I'm going to go right up here at 4, and it's a solid line, so I'm going to go ahead and do my line straight across, and we are going to shade down. All right. So what you guys notice is there is a region that is double shaded. All right, guys? This one, this double shaded region is where the solutions are. Do y'all feel good about that? So, just because there's one shade, that's fine. We want the double shade. All right, guys? So we need double shade here. So, guys, is 8 negative 4 in this solution? Is 8 negative 4? Oh, that's not right. Whoops. Yeah. 8 negative 4. That's correct. 8 negative 4. Is that in our solution here? Is this guy in our solution? Yeah, it's in the double shaded region. Absolutely. Okay? What about 5, 0 right here? It's kind of right on the edge there. But what line is it on? It's on a dashed line. So, y'all, this would be a no because it's on a dashed line. All right? Now, 10, 4... over and out. Here we go. 10, 4. Is this guy in our solution? What do y'all think? It's on a solid line, so that's good news. Does it border the double shaded region? Is it next to the double shaded region? It is. This 10-4 is right next to our double shaded region. So this one is yes. So it's on a solid line bordering, there we go, bordering the double shaded region. All right, guys, are y'all comfortable with that? If we picked any other point over here on this solid line, that would not be a solution because it doesn't border the double shaded region. Only if it's bordering the double shaded region. Are you guys comfortable with that? Awesome. All right, let's take a look at this next one here. Actually, I want you guys to graph these two lines, okay? I want you guys to graph these two lines, and I want y'all to then identify the double shaded regions, okay? Or there's just one double shaded region. So I want you to graph it and then identify the double shaded region there. All right, guys, so before we move on, I do want to show you guys one thing that's unique. I've graphed both my lines. My top line, this y is less than 2/3 x plus 3, and we shade down. So, guys, when I shade down this time, I'm shading to the right. Does that make sense? So that would be if I shade down over here. Y is less than negative x minus 1. This is what my negative x minus 1 line looks like. But when I shade down this time, I'm shading to the left. So y'all, really, the only time you can use left and right is when it's a vertical line. Otherwise, you need to make sure you do up and down. Does that make sense, you guys? So please, so these are both shading down, but one of them kind of shades to the left, one of them shades to the right. And then we see that our double shaded region is this guy down here. So now we can answer all of these lovely questions. Is 0, 0 a solution? Yes, it is. It is solidly in that double shaded region. Is negative 2, 1? A negative 2, negative 1. Is that a solution, y'all? Negative 2, negative 1. Why is that a solution? Yes, it's on the solid line. And it borders the double shaded region. So it's on the solid line bordering the double shaded region. I'm just going to call it the DS. There we go. So it's shorting that. It's bordering that double shaded region. And then 2, 7. Is this guy a solution? Way up here. 2, 7. No, it is on a solid line, but it's not bordering the double shaded region. Does that make sense, guys? So yes, it's on a solid line, but it's not bordering that double shaded region.
So for it to be a solution, it has to be in...
It either has to be inside of it or literally right next to it. Yeah. Does that make sense, Ian?
Oh.
So 0, 0 is because it's literally inside. All right? But it either, or it can be next to it on a solid line. If it's next to it on a dashed line, it's still not a solution. But it has to be next to it on a solid line. Are you comfortable with that? Awesome. All right, guys, so we only have a couple left here. I only have 2 left. But the difference with these next 2 is they are not in slope-intercept form. So what are we going to have to do before we graph it? We got to convert it. All right, guys? So the first one, you need to convert. So we have 2y is less than negative x, plus 6. You divide everything by 2, and we have y is less than negative 1/2 x plus 3. Did I need to flip anything for this guy? I did not, because I did not divide by a negative, so I did not need to flip. Does that make sense, guys? I did not have to flip there. So, we look at this here, and we can graph our first line. We start at 3, Go down 1 over 2, down 1 over 2. Up 1, left 2, up 1, left 2, up 1, left 2. All right, guys? Then we can look at this and we say, okay, what kind of line is this going to be? It's going to be a dashed line, and I'm going to shade down. So I'm going to take my lovely little, take my lovely little ruler here, do my dashed line, and I'm going to shade down. Are y'all comfortable with that? So I do it a little loosely. There we go. Then I'm going to do the same exact thing with the next one. All right. So we have negative 3x. I'm going to subtract that. So now I have negative y is less than negative 3x plus 4. Then I divide by negative 1, and I'm left as y is greater than 3x minus 4. So guys, I had to flip this inequality. I had to flip that one. So I'm going to start at negative 4 with my b, rise up 3, run over 1. Rise up 3, run 1. And again, we're dealing with a dashed line. So when I graph this, it's going to be a dashed line, because it's just a greater than here. So I graph my lovely little dashed line. And are we going to shade up or down? We are going to shade up, because that lovely little P there. So that means we will shade above the line. So we will shade up. So this lovely section here is my double shaded area. That's why I like doing blue and pink, because then it kind of makes a pretty little purple there. Do y'all feel good about that? So now we can answer these lovely questions. Is 0, 3 a solution of the system? Let's see, 0, 3. Is that a solution, y'all? Why not? That's a big no. Why not? It's on a dashed line. Is 0, 0 a solution? Yeah, it is. It's in the double shaded region, very confidently in that double shaded region. Is 2, 2 a solution? Why not? It is not, because it's on the dashed line. So guys, if it's on the dashed line, it cannot be a solution. How are you guys doing with these lovely systems so far? It's not too bad, right? It's not too bad. So what I would like you guys to do is I want you guys to do number 4 completely on your own. I will check you guys off, and then we can get started on homework, and we'll have about 45 minutes to do to work on our homework today. All right, guys? So we will do these guys, and we will see how these guys are. All right? So I want y'all to do number 4 completely on your own, and then we will check here in just a moment. All right, y'all, so for both of these, we have 2 solid lines, and this one was negative, or it was y is greater than negative 2x plus 4, and so it was a solid line, and we needed to shade up there, correct? So we shaded up here, okay? And then for this guy, but it was up and to the right. And then this one, we ended up flipping our inequality sign because we divided by a negative. So it was y is greater than 3x minus 6. We also had to shade up and above it. And so this guy right here is where we have that lovely one. So that would be our double shaded region. And so you guys can see that 0, 4, is that on the solution? Yes, it's on a solid line bordering the shaded region there. All right? 2, -1. Ooh, actually, no, you're right. It is not. That is super not. Not even close. And then 4, 9. 4 all the way up here at 9. That guy is solidly in that double shaded region. So that one is a solution. All right? So are you guys comfortable with this here? Excellent. All right. So we will go ahead and, so now guys, I want you